Welcome back to part 2 of Trig P.1 notes. We were talking about in the last problem finding the absolute value of an equation, or specifically of just a number itself, and I alluded to the fact that all absolute value is the distance between two numbers on a number line. So if you don't want to take the time to actually draw out the diagram and count the distance between, in this case 8 and negative 3, then all you have to do is just take the two letters and the two numbers and subtract them, and then take the absolute value of that. So it doesn't matter the way that you choose to do this, if you call this A and this B, or if you call this A and this B, it doesn't matter, because when we're dealing with the absolute value, we're going to take the positive of it anyways. So I'll call this one A and this one B. So then, by using that formula, it would be absolute value of 8 minus negative 3, and that's going to give me the absolute value of 11, which is 11. Alright, so let's now shift gears a little bit and talk about algebraic expressions when we're trying to solve a problem like this. 3x squared plus 2x minus 5 all over x times 5 divided by 2, and we know that x is 2. What that tells us to do is to plug a 2 in wherever I see the x. So if I do that, it's going to look like this. And in order for us to all get the same answer when we do this, we have to follow Please Excuse My Dear Aunt Sally, or PEMDAS, which is the order of operations. This is the abbreviation that we can use to help us remember the order. P stands for parentheses, E stands for exponents, M stands for multiplication, D is for division. Now normally you do parentheses first, then exponents, then multiplication and division, but you have to actually do between multiplication and division whichever comes first when you're looking left to right in your problem. So you have to do whatever comes first. That means that sometimes you may divide before you multiply. And same thing with addition and subtraction. Whichever one of these comes first when you're going left to right in your equation, you're going to do first. Alright, so when I deal with a problem like this, what I want to do is do my parentheses first. Well, inside of this set of parentheses is nothing, nor this one, and there aren't any in the bottom, so I can go right to exponents. So this is what I'm going to do first. 3 times 4 plus 2 times 2 minus 5 over 2 times 5 divided by 2. Okay, the next thing that I'm going to do is I'm going to do multiplication or division, whichever comes first, left to right. So looking at my numerator, I've got two multiplication parts, so I kind of put this over here. 12 plus 4 minus 5 divided by, then I've got multiplication and division in the bottom. I've got to do the multiplication part first. 10 divided by 2. Then the next thing that I have to do is I have to continue with the fact that I have division. So I have to do 12 plus 4 minus 5 all over 5, do the division portion. And then when you have a fraction like this, you actually need to come up with an answer in the numerator first before you then simplify the fraction. So the next thing that you're going to want to do is simplify the numerator. And again, do addition or subtraction, whichever comes first. So I'd add these to get 16. And then I would subtract 5. So I'd actually get 11 over 5. Reduce that if you can. I'd prefer you leave it as that fraction 11/5. Now I recognize that many of you probably will do many of these steps in your head. You don't necessarily have to show me all of this work, but I did want to go over these rules with you to make sure that you are following these whenever you are solving an expression. The next concept that we're going to talk about is combining fractions through either multiplication, division, or addition and subtraction. And because of the use of calculators, a lot of students forget how to add, subtract, multiply, and divide fractions. When you're multiplying and dividing fractions, you do not have to have common denominators. When you add or subtract fractions, you have to have a common denominator. But because the calculator has done most of this for us, we forget those rules. When you have problems like these examples that we're going to be talking about and you've got variables in it, you can't just plug this into the calculator because you can't put the variables in. So you need to remember the rules for multiplying, dividing, adding, and subtracting fractions. Multiplication, I think, is the easiest out of all of them because all you have to do is multiply numerators together and denominators together. So when I do 3x times 10, I get 30x. When I do 2 times 8x squared, I get 16x squared, and now I start to reduce. So I think about 30 and 16. I know they're both divisible by 2, so I take a 2 out of both. I get 15 eighths. And when I talk about my x's, there's 2 down here and 1 down here, so I can actually cancel out 1 from here. This one would go away. And if I take 1 away from the 2, I still have an x down there. So I'd end up with 15 over 8x. Now to actually divide fractions, what you want to do is you want to change it to multiplication, and the way you do that is you multiply by the reciprocal. In other words, you flip this fraction. Only flip the second one. So we multiply by reciprocal. So I'm going to leave it as 3x over 2. I'm going to change division to multiplication, and it's going to be 8x squared over 10. And now we do exactly what we did over here in the multiplication one. We multiply straight across. Numerator by numerator, denominator by denominator. This time I'm going to get 24. I've got 1x here and 2 more. That makes 3 altogether. And over 20. Dividing this, I can take a 4 out of both of these. So that'd be 6x to the third over 5. And like I said, when you do multiplication and division, you do not need to have common denominators, but you need to have common denominators when you are doing addition and subtraction. So let's take a look at a subtraction problem. So if I've got to find the common denominator between 6 and 9, I can think about what is the smallest number that both divide evenly into, and it's 18. If I can't come up with that right away, the shortcut, or I shouldn't really say shortcut, if you are struggling to find the common denominator, you could just multiply these together and use 54, but then you would have to go through and reduce your fractions when you're all done. If you find the least common multiple, in this case 18 for between 6 and 9, then you know that you shouldn't have to reduce when you're all done. But if you choose to, you know, just multiply these two together to find the common denominator, then you have to do some reducing. So you could use 54 if you chose to. I'm going to choose not to, so I don't have to reduce. Here's the process I need to be saying to myself. If this fraction had a 6 in the denominator, and I want it to have an 18, I've got to times the entire numerator by whatever I need to multiply 6 by to get 18. Well, I know that 6 times 3 is 18, so times up here by 3. And you're going to actually have to use the distributive property when you do that. So I'd make 9s plus 6. Over here, what do you have to multiply 9 by to get the 18? You got to multiply it by 2, so you've got to multiply both of these by 2. So again, distributive property would make 8s minus 10. Once you have the common denominator, you can write it down once, and then take what's in your numerator and combine it. When you do that, especially when it's a binomial that you have to subtract, please include this set of parentheses. And the reason we're doing that is so we remember to use the distributive property. So what we're really going to have here is 9s plus 6 minus 8s and then plus 10. If I forget to put the parentheses here, you'll leave this as a negative 10 and then you'll get the answer wrong. So remember, when you're subtracting and you have a binomial as part of your fraction, insert a set of parentheses. And so when we combine like terms in the numerator, 9 minus 8 is 1s, 6 plus 10 is 16, and then divided by 8. So I end up with 1s plus 16 over 8. Had I used 54, I'd have to go through and reduce all three of these numbers by something, because they would have been different numbers if I used 54, and I would be able to reduce. So if you can reduce, if not, it's already reduced for you, then that's your final answer. So again, just to kind of go back over the highlights here, multiplying, you multiply straight across. You do not cross multiply. You multiply numerators together and denominators together. Division, you want to change it to multiplication. So flip what you're dividing by, multiply by the reciprocal, and then do it just like this problem. Multiply numerators, multiply denominators. And finally, for addition or subtraction, you have to find that common denominator. And then once you find that common denominator, then you just combine the like terms in the numerator and get your final answer.